But in truth, also, the construction cost is this issue of whether you've got engineers in-house or not has a big impact on if you're able to plan in advance and you're absolutely sure that your design's not going to change and you've got your planning absolutely right and you've got all the materials ready and all the drawings ready, that is the biggest contributor to efficiency. And even more so if you're looking into a supplier that hasn't got their own engineering resource. If you're making changes and there's a bit of a mess and constructability is not really being clearly thought through, you have a huge advantage in having a constructor that's got their own engineering team. So part of how you solve the problem is really brilliant planning. And that's really the heart of the problem. I've heard a number of people from the Horizon team say, yes, but we're building the nth of a kind. We're building the ABWR has been operating for years. And I'm looking at them thinking, but you don't know yet how much change you're going to make to your design for UK circumstance. Maybe you'll have a first of a kind, like us. And if you have a first of a kind, then you need to be slightly less confident. All of the experience that you've got. So the real critical, and the UK, we have all of the other types of reactor design apart from a boiling water reactor in the UK. And a boiling water reactor's got some special challenges in the UK circumstance. So I would be surprised if there aren't a large number of design changes. And the really, what I've discussed, I understand now, because I'm not a nuclear engineer, I understand now is that the design changes that we have had a much more profound effect on the safety case and stability of the design than people had understood at the time we agreed to them. And that's a really big issue for creating a reasonable cost. Are you all right with that? Is that clear? Is that okay?
No, one question is now we know the difficulties in the UK. So if the same project as HPC Hinkley Point C on the other country like France, would it be cheaper than HPC project costs? Right, I think it's 18 billions for total HPC project cost. But if you construct in France, will it be changed the cost?
You would have to assume that it was exactly the same site but in a different country, I guess, because and the same. So inside the cost, we account for cost differently in France than the UK. So to give you an example, we are responsible for doing the road improvements in the country for our plant. So, and we have had to build workers' accommodation, and we have to. We've been putting in double glazing in people's houses. It's us that does that in the UK. In France, that's done by the local authority. So there's a lot of our cost, a lot of what we've incurred as a cost, wouldn't be our cost in France. The other thing to remember is that Flamanville, for instance, is built on a site where they planned to build another power station anyway. And in fact, the power station got cancelled after they finished the earthworks. So that they had prepared a site to build a nuclear power plant and stopped it at the last minute. So if you have the opportunity to build on a site that someone was already going to build on, all of the infrastructure is all in place, on site and off site. But as I say, in France, the utility is not responsible for the off site infrastructure. you need to normalise for those sorts of issues. So we have actually a lot of money, it's cost a lot. We built a bypass around the town, we widened roads, changed roundabouts, we're building a harbour, we're building a jetty out to sea, we're building a hotel for 1,500 workers. This is a lot of money. So if you add it up, you'll be surprised at how much it is. So I don't know what the position is in Japan, but in France, most of that we would not be doing ourselves.
So
But the rest of it, I don't know. For sure, it's cheaper in China, which is partly because the craftspeople's pay is less, quite a lot less. But interestingly, there isn't such an enormous difference in the pay of people off the site. So engineers is not so hugely different anymore. What makes a massive difference is that they have built a lot of nuclear power plants recently, and they have an access to a skilled workers. At a time when EDF at Flamerville was struggling, in the liner of the reactor pressure vessel, there's a big dome. It's got a steel lining inside. Those are made of steel panels that get welded together. At a time when EDF was struggling to stay on schedule for the welding because it only had 9 welders qualified to do that welding, in Taishan, just in case there was a problem, they got 27 welders on site. And if they needed some more, they would have just phoned up a construction company and they'd have come along. So that tells you the power of having experienced people.
We also have a lot of experienced welder in Japan. So.
I know.
Yeah.
The other thing that I think is a difference is from what I've seen, and I'm not sure. There's been some great photographs I've looked at of construction sites in Japan, and I think you're much more experienced in looking after the impact of the weather on the construction. So I've seen pictures of a station in Japan with a building over the whole of the nuclear island. You need to be experienced to understand whether it's worth spending the money building a building to save the money in the construction site. That demonstrates experience, and also I think the computer systems that you use to support construction are much more sophisticated than the ones that we used to using, and definitely what they're used to using in France. So I would expect it's cheaper in Japan to go and build a nuclear power plant than it is in France.
So the last question is, in the project cost of 18 billion, what portion is the base capex, excluding financial debt or operators premium? I mean,
there's no. The construction program is about 16 billion.
16.
And the 2 extra is to do with spares and training the operations team and a number of other issues associated. So the core construction cost is something like 16.5 billion. And the rest of it is all the other things that we need. So 18 billion is what we'll spend to get to the point where both units are operating, including everything. It's the cash cost to get both units operating, excluding the revenue for the first unit. So we should get the actual cash outlay is closer to 17 billion, because for that first year, Unit 1 will be operating, the back end of commissioning, so it's not full operation, but it's something like 18 billion is the cash cost, is a cost of getting, excluding any revenue, of getting both units operating, including the need to train an operating team and everything else. Which again is not normally the number that's quoted, but it doesn't include the cost of finance. It doesn't cover interest costs.
Yeah.
It includes money to do with arranging the guarantee with the UK government, but not the interest or cost of drawing on the guarantee. Okay.
Thank you.
And we made this paper to analyze framework of the project of construction, and to analyze the reason of the rise of the WEC project in America.
Yeah.
And I'm afraid that we don't have time because we have to write the Eurostar, which depart 8:30. So
8:30.
so 8:30.
6:30.
So
You said fixed price contract.
Can I send an email to ask the question about these things, or the question that we wanted to ask more?
I mean, it's not very much to add on. Not really. Risk sharing. The construction company owes the upside risk of construction costs.
We made by open source resources, so.
Yeah, but what do you mean by that? That the construction company is taking?
That means
So if the construction company does it for less, they make more money. That's what you're saying.
the contract is fixed price, so
if the construction was delayed, which company should owe the risk? I mean, in WEC case, in Westinghouse case, and the reactor company, I mean WEC, owes the cost of the delay of construction.
I think it's pretty clear that in each of these cases that the operator takes the risk, isn't it?
In the end.
In the end, yes. So the contract, as I said at the beginning, is your hope that a construction company will willfully go bust to allow you to save money is a wish and not a reality. So I think that's the framework is broadly the same as you've written there for flammable brass. The construction you focused on, the civil construction, for us is Bouygues Langeroog. Reactor is Areva. The utility is EDF Energy, UK company. Funding is from the shareholders. Funding and financing is from the shareholders. And we've got a mixture of fixed price contracts. What we've got is fixed price contracts for equipment that's delivered on site, and a target price contract for the erection on site. So if you take all the mechanical